Hello and welcome to this lesson about solving equations, word problems. The learning target for this video is setting up and solving equations from word problems. So I want to talk about the process. The first thing we have to do with word problems, and I always like to stress this, is read, and wait for it, read some more. So the idea with word problems is that we're taking things that you probably know how to do, if I were just to give you the equation, and I'm hiding them in a word problem. So you have to read it. And what I've noticed is that sometimes students first look at the word problem, they see all the words, and they already assume that they can't do it. So I want to encourage you that every time you read it, you might learn a little bit more. So keep trying and keep reading over a problem over and over and over again, and every now and then you'll extract some more details, more information, and you'll slowly start to cook up the equation you need. And so that leads to the second thing, which is set up the equation. So you need to find an equation that will help you solve these word problems. And then finally, or actually there's a couple more things, you'll solve the equation. And then two more details. Both little details, so they're easy to do. First of all, do what I like to call a duh check. Does your answer make sense? So if you're talking about time, your answer probably shouldn't be negative. If you're talking about money, is it a reasonable amount? Just to kind of take a quick look at it and make sure that it makes sense in the context. And finally, this is the big one, but also a tiny detail, make sure that you're answering the question. All right, so sometimes with word problems, you'll set it up, you'll do a bunch of math, you'll get an answer. That's the answer to the equation. You might need to do something with that answer to then answer the actual question that was being posed. So make sure that you do answer the question that's being posed. All right, so now with that being said, let's look at some examples. So I have two different types of examples. This first one is sort of just dry algebra problems. But the point of this is, can we really focus on this idea of writing down an equation to solve it? So first one, the sum of 3 times some number and 4 is 31. So what we're going to have here is an expression that we need to translate. And so this is probably something that you've already practiced and played with a little bit before you got to equations. So the sum of 3 times some number, 3x, and 4, plus 4. Now it's sum because, or it's plus because we saw the word sum. Is always becomes an equal sign, so that'll be 31. We've now set up the equation, and now it's about solving the equation. So we'll subtract 4 from both sides. 3x equals 27. Divide both sides by 3. Notice I'm using a mirror line to help me with this process to make sure I balance out my equation. And I get x equals 9. And now, does that seem like a reasonable answer? It does. Does it answer the question? Well, actually, there really isn't a question. It's just more sort of solve is what we have to do. But there's our answer. X equals 9. All right, let's look at another one. The quotient of some number and 6, oh, that should be minus 10 is negative 9. All right, now quotient, that's a confusing one, but that means division. So we're going to have a fraction, some number and 6 over 6, and then all this minus 10 equals negative 9. So I've set up the equation. And again, it's just about solving. So add 10 to both sides. I'll get x over 6 is equal to 1. Now times both sides by 6. And x equals 6. Box it, walk away. All right, so again, these words sort of just dry, translation of equations that you've seen, and you already know how to solve. And so we were just kind of turning that into a word problem. But now let's look at a slightly harder word problem. So let's say we have this one right here. So this would be number 3. A train averages a speed of 47 miles per hour between two cities that are 117.5 miles apart. How long will it take to get from one city to the other city? All right, so a couple things we can do. One, we can draw it up. So we have city A, we have city B, and we know that the distance here is 117.5, and that the train is going 47. And so we just have to figure out, how many times is it going to go 47 miles over this span here, because it's doing that per hour. Also, there's an equation we could use, which is distance is equal to rate times time. And so if I borrow that equation, I can just plug in what I have. 117.5 is equal to 47, which is my rate, that's a speed, and then times t, time. Well, I just have to divide both sides by 47. And when I do that, and I did a little number crunching on the side here, I get 2.5 hours. Now, this is where I have to go back to that process and see if it makes sense. I've set up the equation, good. I solved it. Do a dot check. 2.5 hours? Seems reasonable. All right, it's not negative, that's good. Now, have I also answered the question? Yes, I have. It'll take 2.5 hours. All right, let's do another one. So this is number 4. You have $20 to spend on food at a sports game. Sports game. You want to buy a soda and some hot dogs. So notice how it says you want to buy a soda, so that means one, and some hot dogs. Well, we don't know how many. If the soda costs $2.25 and hot dogs are $3 each, how many hot dogs can you buy? All right, so what I'm seeing is an equation. I see that I'm going to be spending $2.25 on a soda plus a couple of dollars on hot dogs. Now, I don't know how many hot dogs I can get, but I know they cost $3 each, so that's why I have a 3 there. And then I also know that I only have $20, so I can't spend more than $20. That's kind of my limit. So now, do a little bit of subtraction. So minus 2.25 minus 2.25. And so I have 3x is equal to 17.25. Divide both sides by 3. And x equals 5.75. All right, cool. So now I've done everything. I've set up the equation. I solved the equation. Do a dot check. That makes sense. 5.75. Now the thing is, I need to answer the question. How many hot dogs can I buy? I can buy, I can buy 5 hot dogs. So this is a great example of you do all this work to solve for something, but it's not the answer. You have to answer the question, which is 5 hot dogs. Finally, I have another variation of this same problem, and I just want to show you there are different ways you can set this up. So here, you want to buy a soda and some hot dogs. The soda still costs $2.25, and the hot dogs are still $3 each. But now I have a different question here, or a different question I have to figure out. How much will it cost to get 1 soda and 5 hot dogs? And so my cost is going to be the $2.25 that I'm definitely spending on the soda, plus however many hot dogs I'm getting, which are $3 each. But now I know how many hot dogs I'm getting. 5 of them. And so here, cool. I'm going to have C equals 2.25 plus 15. C equals 17.25. That's how much money it's going to cost to get 5 hot dogs. So, setting up the equation looks a little bit different, but it's still an equation. Got the equal sign. I got my variable, and I'm just plugging in that information, and then I'm working on finding the answer. Do a dot check. It works. And then also just see, how much money, or make sure I'm answering the question, which I am. How much will it cost overall? So that's word problems. Just to recap everything. Read, and read. Then work on setting up the equation. solve the equation, do a duh check, and then make sure you're answering the question that was asked of you. Good luck on your homework or practice, and let me know if you have any questions.